Welcome. Today, we're diving into the full journey of working with IBM API Connect. From the complete setup guide, through API management, to the analytics subsystem, we'll cover every phase and every command you need. This step-by-step walkthrough is designed to get you confident and productive with the platform. Let's get started. We're looking at a 5-phase process that each subsystem follows, with parameters tailored to its specific role. It starts by initializing the project, then adding the subsystem, configuring it, generating the ISO, and finally validating everything. This flow repeats across 3 key subsystems: Drupal CMS, Elasticsearch Analytics, and the API Designer within the Orchestration Hub. Each one produces its own ISO, all fitting into a unified topology. It's a clear, consistent framework that keeps the whole system aligned. Before we create any ISO, we need to get a few things in place. First, verify that the apicup binary version matches your IBM API Connect stack exactly. Make sure the OVA file is downloaded from IBM Passport Advantage and accessible to the apicup host. Storage needs to be ready, whether NFS, Ceph, or VSAN, with the right capacity for portal, analytics, and management nodes. Networking must be set up properly, including open TCP ports, load balancer VIPs, DNS records, and NTP sync. Finally, confirm the software environment is complete, with kubectl, a valid kubeconfig, and the IBM OVA file all ready to go. Now let's look at the 5 key phases of our project workflow. We start by initializing the project, laying down the foundation. Then, we add the management subsystem, which keeps everything organized. Next, we configure all the parameters to fit our needs precisely. After that, we generate the ISO, the packaged output. Finally, we validate and deploy, making sure everything works smoothly in the real world. This structured approach keeps us on track from start to finish. Let's start by initializing the project. We run the command to create a new project scaffold, which sets up the basic structure we need. Next, we enter the project directory. This step is crucial because all future commands depend on being inside that folder. Then, we verify the scaffold was created by checking for the manifest file. Remember, never hand-edit this manifest. Always run commands from within the project directory to keep everything working smoothly. This is the foundation for managing all 3 subsystems in one place. Now we're setting up the management subsystem, and here's a key point: the alias MGMT will be used in every configure, install, and validate command that follows. So, pick a short, meaningful name because once it's created, you can't change it. We create the subsystem right inside the project directory, then verify it's registered. At first, the parameters will be empty, but this step lays the foundation for everything else to come. Let's look at how to set all the hostname and fully qualified domain name parameters in a single command. This approach saves time and keeps everything consistent. We specify the management node's hostname, the DNS search domain, and several API endpoints, including the Cloud Manager UI, the REST API, and Platform and Consumer APIs. Some parameters are required, others optional, depending on your setup. This step is key to ensuring all parts of the system communicate correctly. Let's take a closer look at sizing and configuration for the management subsystem in Kubernetes. Here, we're setting up a production environment with 3 Cassandra replicas, each allocated 9 GB of RAM and 50 GB of persistent storage. For development or testing, a single replica with smaller resources is enough. We specify the Kubernetes namespace, storage class, and enable high availability by creating custom resource definitions. These settings ensure the management pods run reliably and efficiently within your cluster. When it comes to managing TLS certificates in the management subsystem, we have 2 main options. Option A is the default, we do nothing, and the system uses auto-generated self-signed certificates. This is simple, but it's mostly suitable for development or testing. Option B lets us inject custom TLS certificates, which involves specifying the hostname and providing the server certificate, key, and CA chain. This approach helps avoid browser warnings and ensures proper validation, but it requires careful matching of domains and importing custom CAs into browsers. Before we generate the ISO, always run the validate command first. It takes less than a minute, but skipping it can cost you 10 to 30 minutes if the build fails. For standard ISO creation, we use a simple command specifying the output file. In air-gapped environments, we need to explicitly provide the OVA path. Once generated, verify the ISO's size and checksum to ensure integrity. This step bundles everything, from the VM template and certificates to configuration data, into a ready-to-use, bootable image. Now let's talk about the critical step of validating and deploying the management subsystem. Before generating the ISO, we always run validation to catch common errors, like expired certificates, missing storage classes, or DNS lookup failures. We check that all required fields are set, certificates are valid, and DNS resolves properly. After the VM boots, we complete the Kubernetes deployment from the apicup host, sometimes skipping TLS verification for self-signed certificates. This careful validation ensures a smooth, reliable deployment. Here, we see a step-by-step command reference for setting up the management subsystem. It starts with initializing the project, then creating the management type subsystem. Next, we configure essential settings like host names, namespaces, and storage classes. We also set Cassandra cluster parameters to optimize performance. Optionally, certificates can be applied for secure communication. Finally, the commands include validating and deploying the subsystem, either as an ISO or post-boot. This sequence guides us through a complete, hands-on setup process. Let's dive into the analytics subsystem and see what makes it tick. At its core, it uses an Elasticsearch-based metrics store. That's number one. On top of that, we get detailed API call statistics and dashboards, giving us clear insights at a glance. Then there are key performance metrics like latency, error rates, and throughput crucial for understanding system health. It's integrated with the API Manager's management subsystem, streamlining control. And finally, this subsystem can even be installed separately on dedicated nodes, offering flexibility and scalability. When it comes to scaling analytics, there are two main approaches. You can isolate it completely, creating a separate project. This is great for high-volume production, keeping things clean and focused. Or you can co-locate analytics within the same project as management, which simplifies setup and works well for smaller deployments. We'll walk through how to initialize a new analytics project, add the analytics subsystem, and verify it's properly registered, whether you choose separate or shared projects. Now, we're diving into the key parameters for configuring the analytics subsystem in Phase 3. These settings cover everything from memory allocation for coordinating Elasticsearch nodes to storage classes and volume sizes. We specify namespaces to ensure everything aligns with management and define endpoints for both data ingestion and dashboard access. Each parameter plays a crucial role in building a high-availability Elasticsearch cluster, making sure our analytics infrastructure is reliable and scalable. This slide lays out the essential values we need to get it right. Now that we've generated and deployed the necessary ISOs, it's time to register the analytics endpoint within Cloud Manager. You can do this through the UI by navigating to Settings, then Analytics, and adding the analytics service with the client URL. Alternatively, you can use the REST API to post the analytics service directly to the management subsystem. Next, we link analytics to management by configuring core hostnames and endpoints. Finally, we set up Kubernetes and Elasticsearch storage parameters to complete the analytics subsystem configuration. Let's talk about sizing and deployment for the analytics subsystem. For large setups handling over 10 million API calls a day, we recommend 5 or more data nodes, each with 500 gigabytes of storage and 32 gigabytes of RAM. Medium setups use 3 nodes with 200 gigabytes and 16 gigabytes of RAM. Small setups get by with 1 node at 100 gigabytes and 8 gigabytes of RAM. Then the slide walks us through 4 key steps: validating the configuration, generating the ISO file, verifying that file, and finally completing deployment after boot. These commands help ensure a smooth, reliable setup. Now, we're looking at the complete command reference for the analytics subsystem. These commands guide us through setting up and configuring the analytics features step by step. We start by creating the analytics subsystem, then move on to specifying host names and storage details. There are options for certificates, validation, and even generating an output ISO. Each command builds on the last, giving us full control over the analytics setup in a clear, structured way. Let's take a closer look at the portal subsystem, which is all about making the developer experience smooth and efficient. At the core, we have a Drupal-based API consumer portal. This is where developers interact with the APIs. Then, there's self-service for API subscriptions and keys, so users can get what they need without waiting. Community forums and onboarding tools help bring developers up to speed. Finally, separate ISO environments must link back to management, and fully qualified domain names are required for both portal admin and the public portal. Let's break down the structure of our developer portal and how it all fits together. We start with the public-facing site. That's where consumers interact. Behind the scenes, there's the admin interface and API, built on Drupal, which manages portal registration and configuration. This management subsystem orchestrates everything. To get started, we initialize the project and add the portal subsystem using command line tools. Whether you keep it in the same project or separate, this setup lays the foundation for phases 1 and 2 of the developer portal. Now, we're diving into the crucial step of configuring parameters for the developer portal in phase 3. Here, we set everything from the site's display name to storage sizes for both admin and web data. We specify the storage class, the Kubernetes namespace, and the portal's URLs, both consumer-facing and admin endpoints. Each parameter plays a vital role in ensuring the portal runs smoothly and scales properly. This setup is the backbone that keeps the portal reliable and ready for users. Now that both subsystems are deployed, we need to register the portal within Cloud Manager. You can do this through the user interface by entering the portal admin URL. Alternatively, there's a command line option using the Management REST API for automation. After that, we configure the portal's core settings, like hostname and domain, followed by Kubernetes and storage details. This final step ensures the developer portal is properly connected and ready to go, completing phase 3 of the setup. Now, let's look at how we secure the developer portal with TLS certificates. Unlike the management interface, the portal needs certificates for 2 separate endpoints. One is for the consumer-facing website. That's the main portal users visit. The other is for the admin API, which handles backend communications and management tasks. We set these certificates using the apicup tool, specifying the hostname and the paths to the certificate files. This step ensures all traffic is encrypted and secure. Now, let's focus on the critical steps for generating and validating the portal ISO. First, we need to ensure the management subsystem is reachable from the portal node. We verify persistent volume claims for both www storage and admin storage, and confirm that TLS certificate hostnames match their fully qualified domain names. Both portal admin and portal www FQDNs must resolve correctly. Then, we validate the configuration before generating the ISO. After creating the ISO, we verify the output file's integrity. Finally, post-boot, we complete the Kubernetes deployment to wrap up the process. Here we have a complete command reference for the developer portal subsystem. It walks us through the key commands, starting with creating the portal subsystem itself. Then, setting host names, namespaces, and storage options. We also see how to configure certificates for secure communication. Finally, there are commands for installing the portal, validating it, and generating output like ISO files. This sequence outlines the essential steps to get the developer portal up and running smoothly. Here, we have a side-by-side comparison of key configuration parameters across 3 subsystems: portal, analytics, and management. This slide helps us see how settings like storage size, replica counts, and fully qualified domain names align or differ between them. By comparing these parameters directly, we get a clearer picture of each subsystem's setup, making it easier to manage and troubleshoot the overall system. It's a practical reference for anyone working across these components. When we're deploying in production, there's a recommended sequence to keep everything running smoothly. Always start with the management system. It's the foundation that analytics and portal depend on. Next, deploy analytics, then portal. After each boots, we register them in Cloud Manager to keep everything connected. Once all subsystems are registered, we link analytics and portal to management through the topology. Finally, we verify the full stack is operational by creating a test API, publishing it, and checking the portal with an end-to-end test. This order helps avoid issues and ensures a solid deployment. That wraps up our deep dive into deploying IBM API Connect using the apicup CLI on Kubernetes. We move through 5 clear phases for each subsystem, from initialization to configuration, then generating and validating the ISO files. Whether it's the portal, analytics, or management components, the process stays consistent. When you see ISO creation complete, you know the deployment is ready to go. This structured approach helps keep everything organized and reliable. This video was created with SlideSpeak. Visit SlideSpeak to turn your presentations into engaging AI-narrated videos.